number 9024. It has no value, so why don't we leave it out? Why don't we leave it out? So you have to give a reason there. So number 8 and 9, you have to reason. So yet you have to go through what I have said and you pick up the reason. Why are we not leaving it out? So that is the activity. I hope and wish you would do it right. Well, I hope you have enjoyed this lesson. I hope you have learned so much in this lesson. Keep safe. Remember to sanitize all the time. And keep safe. Enjoy and goodbye.
Hi everyone, I'm Joshi. And make sure to always make a helicopter circle, stretching your arms out and spinning around like me. And make sure you're not touching anyone while doing this. Goodbye.
Grade 12s. We are looking at the workshop questions on geometry. This is 3 recorded lessons, and this is the first one that we're going to look at now today. The surface area of a sphere is given with this formula. So they provide you with a formula. You don't need to learn it. Calculate the surface area if the radius is 5. So I'm just going to substitute 4 pi 5 squared. And now I must do that calculation on my calculator. I like to start there with a square, not to make a mistake. So it is then 5 squared times, and at the bottom of your calculator you will see there is that symbol P, but we need to use shift pi, and then times 4 is equal to, and I have 314. 314. You can give it in terms of pi, but you can multiply it out also. The second one is actually algebra, where we have to change the formula, but this is why we are doing it. And R must now become the subject of this formula. So to have R alone here, I'm going to divide by 4 pi. Is equal to R squared. And then in a second step, to get rid of the square, I root it, which is the opposite operation. But what I do on the one side, I must do on the other side. So I'm going to square root this one, but I also have to do it here. So it is A over 4 pi, which is equal to R, changing the formula. You do with the letters what you do with the numbers. Right, question 2. There's a running track each of length 120, and then 2 circular ends. Now, the first one is calculate the total length of the curved sections of the track. It is a 400-meter track, so then it's 400 minus twice 120. And they want the total length, so we don't need to divide it by 2. So 400 minus twice 120 is then 400 minus twice times 120 is equal to 160 meters. And then they say, calculate D, the distance between the parallel straight sections of the track. Now, this is, because it is the 2 curved surface areas, this will form a full circle. So that means that that is actually the circumference that we have there. So the formula that we will use here is circumference is 2 pi r. And we know now that the circumference is 160. So to have r alone here, we will divide by 2 pi. And you divide by 2 pi here. So on your calculator, let's press the calculator, 160 divide by brackets 2 times shift pi there at the bottom of your calculator, close, is equal to, and now I have now 25.46, but now remember, this is the radius, and we want the diameter, so we'll have to multiply that radius by 2. So the final answer for this one is then 50.9. 50.9. That is the final answer there for number 2B. Number 3. Calculate the size of one exterior angle of a heptagon, giving your answer to 1 decimal place. Now we know all polygons, for all polygons, the exterior angles are 360 degrees. A heptagon is a 7-sided shape, so we just divide it there by 7, the exterior angles, and it is then 360 divided by 7, and the answer is 51.4. 51.4. Right, the next B part of this question, we've got parallel lines, so that means we have co-interior angles, alternating angles, and corresponding. In the diagram, there's the parallel lines, and we've got that this angle is 130 degrees. What is the special name given to this triangle? And we can see that this is an isosceles triangle. An isosceles triangle because we've got 2 equal sides there. And now we have to calculate all the angles here. So P is going to be, this is a straight line, 180. So P is going to be 50 degrees. Because it is isosceles, R must also be 50 degrees. Can you see? P and S are alternating here. So this one is also 50 degrees. We've got a straight line here. If this is 100, it means T is going to be 80 degrees there. And here in the triangle, or working with alternating angles here, this one is also 80 degrees. So there are then the sizes of all the angles. Right, the second one. We've already done that now. There's a circle. What do you know about a circle? We know that the angle in a semicircle is 90 degrees. That's what we know. So this is a triangle then. So these two must also add up to 90 degrees. And that gives me then 90 minus 65, which is 25 degrees. 25 degrees. Question 4. The diagram shows a swimming pool with cross-section A, B, C, D, E. The pool is 6 centimeters long. So here you've got a nice picture of how it looks like. Calculate the area of the cross-section here. This is the one that we have to calculate. We don't have a straightforward formula here, so we'll have to divide it into 2 areas. Here's a rectangle, and then this one is a trapezium. So the rectangle here will then be 2 times 3.6, the rectangle there. But now we'll have to calculate the trapezium on this side here. Now, if you turn it around, you'll see that this is actually your parallel lines, and this is the height that we have there. That's the height then there. Now, if this one is 3.6 and that one is 6, it means this part here is also 3.6. So we can subtract the 2 there from each other. And then we can see that this one is then 2.4. Yeah, that part there, the height there is 2.4. So this is also 2 meters there, and this one is 1 meter. There we can see it's 1, and this one is 2. So this is a trapezium. The formula for a trapezium is half height A plus B. So this is then going to be a half of the height, which is 2.4, and A plus B are your 2 parallel lines, which is 2 plus 1. That's how you calculate that one then there. So the total area is 10.8. 10.8. This one is 6.
Win free airtime with One Africa TV. Share your comments on the channel. SMS your feedback, name and town to 555. One Africa TV. It just gets better.
Akili, 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 akili. Let's chase the germs away. Let's chase the germs away by keeping our hands clean. And when you want to sneeze or when you want to cough, do it in your elbow. Let's practice sneezing into your elbow. Are you ready? 1, 2, 3. Achoo! Again. Achoo! Yay! You did it! Germs, germs, germs. They make us sick. Germs, germs, germs. Germs, germs, germs are not your friends. When you're sick, you sneeze. Achoo! When you're sick, you cough, cough, cough. And if you achoo or cough on your hands, the germs stay alive on your hands and get passed on to your friends, and they'll get sick too. Let's chase the germs away. Let's chase the germs away by keeping our hands clean. And when you want to sneeze or when you want to cough, do it in your elbow. Germs, 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 they
So let's start with that question 69. This was a very easy question. A company makes two models of television sets. Model A is a rectangular screen and model B has a larger one. It's increased in the ratio 5:4. Calculate the new measurements. Now that is very, very easy. This is then question 69. Because what do we do if we enlarge it? You just put your ratio 5/4. It's not sharing, because that's what some learners do. It's just the bigger one which comes on top. And what is the new dimensions? Yes, and? Yes, that's the two new dimensions, yes. No, it doesn't work. Yeah, but it must be in the ratio 5:4. What happens with this increasing of a ratio, it's an automatic increase. It automatically increases if we work with this one. So this is how we need to do it. And then they say the area. What is the area? Now, what do you know what happens to the area? Yes, what? This ratio, isn't it? So, I'm going to need to, but look what they say, A to B. So it's the small one to the bigger one. So it is then 4/5, which we square. Ek dink hulle sê give it as a fraction. Yes, so it's 16/25. 16/25. Easy question, but you forget this. Oh. Okay, question 68. Calculate the area of an equilateral triangle with sides 10 centimeters. There's the equilateral triangle. Now, there's two ways. But what is? Okay, so you can work, but then remember that one is 5. So I can half base height, calculate that side, and then get the area. Or you can work with any triangle, half BC sine A. And we know that an equilateral triangle is 60 degrees. So that's another method to do it. The answer on that one is... Oh, kom het ek? Kom dan nou nie. Oh, 43. You need to calculate the heights first. So it's 43.3. So it's 10 squared minus 5 squared to get the height. And then it's half base height. Or you work with half BC sine A. Again, lots of learners had this wrong, which is unnecessary. Okay, now, number B. Calculate the radius of the circle with circumference 10. That's very easy. Circumference is 2πr. And you just calculate R. R is 1.59. Okay, but we're going to use this now in the next question. That's why I write it down. But that's that's a question that we ask grade 9s. Then number C. The diagram represents the nets of 3 solids. Each straight line in each diagram is 10 centimeters. Each circle has a circumference of 10, and the arc length in diagram 3 is also 10 centimeters. So name the solid with the net 1. Luan, what is that? 1. Diagram 1. You must tell me. What is the name of the first diagram the solid? Wat noem ons hom? Yeah, but that's not good enough. Pyramid is not giving triangular pyramid or a tetrahedron. Yeah, square base, a pentagonal, you get a lot of pyramids. Jy kry nie vir pyramid 'n punt nie. A triangular pyramid or a tetrahedron. Nee, daai een is die tetrahedron. Daai een is die tetra. It's a square-based pyramid. And then, ja, maar dis hoekom ek sê, jy moet sê, dit kan ook 'n punt wees, né? Look at that one. Then, calculate the volume of the solid whose net is diagram 2. So what will this be? What is the volume of the cylinder? What? 2PRH, isn't it? Yeah, the volume. Ah ja, skus juffrou is nou by surface area. PR squared H. Nou nie my liedjie vir julle hier oor die ding sing nie, so. Okay, and it is 79.4. I use this radius length that I got here now, and it's then 79.4, so very easy, very, very easy. But let's look a little bit at number 3. Calculate the perpendicular height of the solid whose net is diagram 3. So this is a cone. It's a cone that you have there. Look that they also say the arc length is also 10 centimeters. So how will we calculate that perpendicular height now there? But this is an arc length. Okay, so with Pythagoras, which two sides are we going to use? 10 squared minus that 1.59 squared. The radius, minus the radius. And the answer was 9.87. Okay, so that was last year's 2 questions. I think daar's nog een, hè? Number 67, which was the Lauki. Okay, look at question 66. Yeah, daai ene. If you look back, number 10, exactly the same question. It was number 10. Okay, so I would also ja, maar julle kry dit. Give reasons, explain why triangles QOT is similar to QRRS. So why will they be similar? So you have to look at that. You always have to show Q is equal to Q. Why is O equal to R? This is corresponding me, and T is equal to S is equal to 90 degrees. So this is a common angle. Q is a common angle, and this too is 90 degrees because it's the tangent there. It's a tangent that we have there. Obviously, then your third angle will be equal. So that's how we show similarity. Don't say the angles are equal. You must show which one is equal to which one. They ask this quite often. Ten minste 2. Jy moet this Q and Q is common. This is 90 degrees, so obviously O and R will then be equal. Yeah, but show which angle is equal to which one. They love this question. Yeah, well, usually you will get your 2 marks there for the 2 angles that you can show. Oh, the third one is automatically the same. But don't just say angles are equal. Which one? Which one? Then they say, find the length of OT, the radius of the circle. Now, hence means I need to use similarity. Okay, but let's first now look at this picture. What is equal to what? There's a circle inside. I hope you can remember what we did because we did this question. Okay, so this one is 13. This one is 10. So this one can be 5 here because this is the midpoint. Right. Now, what I want to know now, what is the length of this one and this one? Why? Yes, yes, yes. This one is also 5 because 2 tangents from the same point are equal. This one is not, it's not 6.5 because that's what the learners tell me, half of 13. No, 2 tangents from the same point are equal. So this one will be 8. And what about QS? QS? Wat gaan QS wees? Hoe? Met wat? Okay, so 13 squared minus 5 squared is equal to 12. Okay. Ek gaan, maar ek moet nou eers die sye kry om die similarity te gebruik. Jy is heeltemal reg. Maar but I need to kyk net hier vir my. Die groot fout is learners say this one is 6.5 and it's not. Omdat hy lyk of hy in die middel is hy nie in die middel nie, né? Look at the facts that we have there. So from there I'm going to use similarity now. And the 66, so the similarity is going to say, so ek gaan nou net hier vir julle skryf watter sye oor watter ene. So OT over 5, let's just see if you can see it. OT over 5 is equal to 8 over 12. So I had to get those sides first. From there it's easy, cross multiplication, and then so I get that OT is 3 1/3. But it was difficult here for the learners to see which sides. Again, I used an old question. Right, let's go back. Question 65. Yeah, also an extended, 65 and 64 are old extended questions. So, if they can do it, you can do it. The figures in the diagram shows lengths in units. For each of the 4 diagrams, write down the fraction of the total area, yeah? Hoe kom? Ag nee, Louis, nou maar moet ek jou weer terugkyk. Okay, kom ons kyk nou. Wag, dis reg. Ekskuus, ek moet nou net op die oorspronklike kyk. So I say OT over 5. Nou wat sê jy is verkeerd? Nee, jy werk met die ander 3 keer. Onthou daai 2 goed draai om. Hulle draai om, né? Daai 2 goed moet omdraai. Daai 2 driehoekies moet omdraai. Maar as jy sukkel met dit, dan moet jy hulle met tracing paper maak dat jy kan sien daarso. Ek dink is reg nou, maar werk uit as jy stry. Okay. Stry, okay. Right, the next one, so we're looking now at question 65. Kom ons kyk gou na daai ene. So what would you say, what area is the shaded one, the first one? Is? Diagram 1 is a quarter. Yes, thank you, that's right. Number 2, what will that shaded area be? Ja, ek het nou die antwoord gehoor. 1 out of 8. Because can you see that a parallelogram, 2 triangles forms a parallelogram? So that's why it's a half of this one. That's what makes it 1/8 there on that one. The parallelogram, a parallelogram can be cut into 2 triangles. So then you can actually draw 8 triangles in there. That's why it's 1/8. Perhaps it's a good idea to draw them also to see and find them there. Okay. Right, number 3. Hoekom? Hoor Anina se verduideliking, sê weer. But again, you will be able to divide it into triangles there. It is then 3 out of 8. 3 out of 8. You can also look at that, this is the half of that side, isn't it? So this will be 4 or a half of it. And this is then 3/4, so it's a half of 3/4, and this is how I get the 3/8. Can you see? And then the last one, for each of the 4 diagrams, write down the fraction of the total area. Again, look at that little triangle there at the top. If you draw triangles in here at the bottom, if you draw that size triangles in there, then you get, then it's 3 out of 5 triangles there, 3 out of 5. So the best was to draw them in there. Ja, binne inteken. Maar goed, onthou nou, julle het nou nie kans om dit lekker deur te lees en 'n bietjie te deurdink nie, dis kom dit vir jou nou moeilik is. Ek gaan nou bietjie vinnig en jy het nie regtig kans om te dink wat om te doen nie. So dit is miskien maar nou net hoekom maar ons probeer nou maar net vir jou vinnig daar wys. 64 is, ek dink hy kom uit 1994 van Extended, daai vraag, maar 'n lekker enetjie. Okay,